Decision trees, the one of the most used algorithms and one of the most, you can say, versatile and ease of use, and one of the first algorithms that comes into a mind for the business to lay down and see how the business is using that particular output. So how can we define a decision tree? In simple words, it's a machine learning approach that uses inverted tree like structure to model the relationship between independent variables and the dependent variables. They are supervised machine learning models, and it means that we know we are what we are predicting. We have the label as well. That's why we are able to predict the future outcomes, and because of the versatility and ease of use, the decision trees are one of the most widely used machine learning approaches. Just like a tree has a trunk which is connected to leaves of the branches, a decision tree is a collection of decision nodes which are connected, uh, to other decision nodes by leaf nodes and by the branches that are there. For example, we can also think of a decision tree as a collection of questions, responses, and outcomes. We have data to know whether a particular customer is going to default or whether we should give him a loan or not. So we have data like his annual income, the loan amount, and we can build a decision tree to know the profile of the customer and whether we should give him a loan or a not. Being a very good machine learning algorithm and being very you can say optimum, and but the problem is it overfits. That is one of the issues in decision tree, that it understands the training data so well that it overfits. This means that the model will perform very well on the training data, but will not be able to generalize so well on new unseen data. Maybe it may be cross validation data or the test data or a new data that we are about to score. So to counter this issue, what we need to do is there is a method called pruning, which is used to combat overfitting in the decision tree. By pruning away some of the branches of the tree, we can reduce the complexity of the model and make it generalize more well on unseen data. The same way that we remove important variables from logistic regression or linear regression, just like the concept of R square and adjusted R square, according to the number of parameters that are required to explain the variability. Similarly, we are removing the unimportant branches which are not helping us predict the outcome in a proper way. So there are mainly two types of methods: pre-proning and post-proning, but we generally as a data scientist focus more on pre-proning, which is a very common method, and it involves stopping the tree from growing at a certain point before it becomes too complex. And this can be done by setting one of the main parameters that we use to build a decision tree, that is the maximum depth of the tree. We can start with a minimum minimum max depth, and we can optimize it accordingly. And then the second option is also by setting a minimum number of samples that are required at each leaf node. So we can iterate on these two main parameters, and we can help the decision tree to optimize and give us a good output in unseen data. It is a very important technique, pruning, for building a better decision tree, and it can help to improve the overall machine learning model. So that's it about pruning and decision tree. Have a great day. Thank you.